Hey there, all you cool cats and kittens. Sorry, I just thought that was funny. So welcome back to Algebra 2. I'm Miss McGuire, and I'm going to walk you through today's lesson. So today we're going to be doing Unit 1, Lesson 3. And this is just a friendly reminder that if you are doing your notes on paper, or even if you printed these guided notes out, you need to make sure that your first and last name are written at the top right-hand corner. The period and the date followed, please. All right, so today's topic is we are going to be solving absolute value equations. So we get to do solving absolute value equations. So this should definitely be a review of something that you learned in Algebra 1. Today's objective is I will be able to solve absolute value equations, finding both solutions, and checking for extraneous solutions. All right, so this objective includes a couple things that I just want to point out. So the first thing is I wrote both solutions. So when you solve an absolute value equation, you're going to get more than one answer. You're going to get two answers. And you're going to have to take those two answers and you're going to have to check them to make sure they both work. And if one doesn't work, it's what we call an extraneous solution. So an extraneous solution is a solution that you get when you solve the equation, but when you plug it back in, it doesn't actually work. So it's a solution that you get when you solve the equation, but it doesn't make the equation true. So the key word that I like to pay attention to in extraneous solution is this word extra. So it's an extra solution that you totally get. It's legitimate. You get it when you solve the equation, but when you plug it back into the original equation, it doesn't make it true. Okay, so that's what an extraneous solution is. Now we need to discuss absolute value. So absolute value is a little tricky because absolute value has something that you need to look out for, and that is, I'm gonna give you an example. Actually, wait, I should remind you what absolute value is. So if you recall, absolute value is the distance a number is from 0. The distance a number is from 0. For example, the absolute value of 5 would be 5 because it's 5 units from 0. The absolute value of -3.5 would be 3.5 because it's 3.5 units away from 0. So here's what we need to talk about though. So if you have, let's say, the absolute value of 3, well, how far away from 0 is 3? 3, right? So the absolute value of 3 is 3. What about another number though? Is there another number that also has an absolute value of 3? Is there another number that is also 3 away from 0? Well, what about the number -3? How far is -3 from 0? Isn't it also 3 from 0? So as you can see, there are two different numbers. 3 and -3 both have the same absolute value. Two different numbers have the same absolute value. So what that means is that anytime you have the absolute value of x is equal to, let's say, 5, well, what number could x be? What number has an absolute value of 5? Doesn't 5 have the absolute value of 5? But isn't there a second number that has the absolute value of 5 as well? It would also be negative 5. So the absolute value of 5 is 5, and the absolute value of negative 5 is 5. So anytime you have an absolute value equation, you have two answers. You have two possibilities. So let's jump into an example and see how that works with an equation. So in example 1, we have the equation, the absolute value of 2x minus 1 equals 5. The first thing you need to look out for when you solve an absolute value equation is that the absolute value is isolated on one side. So it's just the absolute value, whatever's inside, is equal to everything else. Well, here we have that. The absolute value of 2x minus 1 is equal to 5. So from there, I recommend you show your work this way. You're going to have two different equations that you have to solve because we need to find two answers. You're going to have 2x minus 1 is equal to positive 5, and 2x minus 1 is equal to negative 5. So you have the positive version of the equation and the negative version. So when I say positive and negative versions, what I mean is whatever was equal to the absolute, whatever was inside the absolute value gets left alone. So 2x minus 1 was inside, 2x minus 1 was inside. I didn't change anything about that. All those signs stayed the same. What changed was what the absolute value was equal to. So here the equation is equal to 5. So I have positive 5, and then I have negative 5. So that's what I mean by the positive and the negative for both of those things. Okay, then the other thing I want you to notice is we started with absolute value symbols with the equation, but when I rewrote it, I dropped the absolute value symbol. So when you solve the absolute value equation, you drop the absolute value sign, you set it equal to the positive and then to the negative. All right, so now you have two separate equations that you're going to solve the same way you solve equations. We're going to add 1 to both sides, and then we're going to divide by 2, and we get x equals 3. We're going to add 1 to both sides. We get negative 4. We're going to divide both sides by 2. X is negative 2. So we have two answers, x equals 3, and we also have x equals negative 2. We have two possibilities that will make this equation true. What we have to do is check both solutions because one or both could be extraneous. So we got to look for those extraneous solutions. So the absolute value of 2x minus 1 equals 5. When you check it, you want to plug it into the original equation. You want to plug it into the one with the absolute value symbols. So we're going to do the absolute value of 2 times 3 minus 1 equals 5. So 2 times 3 is 6. 6 minus 1 is 5. Is the absolute value of 5 equal to 5? Yep, that worked. Okay. Now we're going to check the other equation, which I did not leave very much room, huh? Okay. Sorry, we're going to check the other answer. So we checked 3, it works. Now we're going to check negative 2. So x is equal to negative 2. Don't know what I'm writing there. Okay. The absolute value of 2 times negative 2 minus 1 is equal to 5. So 2 times negative 2 is negative 4. Minus 1 is equal to 5. I'm going to come over here. Negative 4 minus 1 is negative 5. So the absolute value of negative 5 is equal to 5, which is a true statement. The absolute value of negative 5 is 5. So hey, both solutions worked. So the way you're going to write your final answer is you're going to write x is equal to 3 and then a comma and then negative 2. So x equals 3 and negative 2. We have two solutions here. So let's move on to example 2. So for example 2, I'm going to help you get set up, and then I want you to solve it on your own. So remember, when we solve an absolute value equation, we have to separate it into two equations because we need to find two separate answers. So first of all, you make sure the absolute value is isolated on one side, which it is. Then you're going to split it into the positive and the negative version. So the positive version, drop the absolute value sign. 3x plus 2 equals 4. And then the negative one, 3x plus 2 equals negative 4. Just as a reminder, you take what it's equal to and you do the positive and the negative. Everything else stays the same. So now what you're going to do is you're going to solve this equation on your own, and then check back with me when you're done to make sure that you did it correctly. So go ahead and pause the video and see what you get. All right, so when I solve this equation, I subtract 2 to both sides. I get 3x is equal to 2. I divide by 3. So I get x is equal to 2/3. In the other equation, I get 3x is equal to negative 6. Divide both sides by 3, x equals negative 2. So again, we have our two solutions, and we need to check to make sure one or both of them work, because if one doesn't work, or maybe both don't work, they're extraneous solutions. Whenever you have an absolute value equation, you gotta check your answers. So when you check them, you should have plugged them into the original equation. And I'm going to replace this with this first x with 2/3. Something really handy happens because 3 times 2/3 is the same thing as 3 times 2 divided by 3. Well, what's 3 divided by 3? Those cancel, right? And we're left with 2. So 2 plus 2 is 4. So the absolute value of 4 equals 4. True statement. All right. Moving on to x equals negative 2. So again, we're plugging it into the original equation with the absolute values and all. So the absolute value of 3 times negative 2 plus 2 equals 4. 3 times negative 2 is negative 6. Negative 6 plus 2 is negative 4. And the absolute value of 4 is positive 4. So hey, both work again. So your final answer is x equals 2/3 and negative 2. All right, moving on to example 3. So in example 3, this is where they get a little tricky, because as you can see, our absolute value symbols here aren't isolated on the right-hand side. No, the left-hand side, because I know my right and my left. So on the left-hand side here, we've got this +1 and this -3 hanging out with our absolute value symbols. So we need to talk about what to do to isolate the absolute value. So we want to get these absolute value symbols alone. So the first thing I'm going to do is I'm going to add 1 to both sides. And I get -3 times the absolute value of x plus 2 is equal to -9. Well, for a second, I thought, wait a second, is this allowed? I have an absolute value equals a negative. And don't absolute values always need to be positive because the distance can't be negative? Well, yes, that's true. However, what happens if I divide both sides by that -3? And now the absolute value is completely alone. But -9 divided by -3 is +3. So the absolute value is actually equal to this positive number. So it actually is okay. After you isolate the absolute value is when you want to assess, can this be true? So I'm just going to move this up here, and I'm going to get So I have the absolute value of x plus 2 equals 3. I'm going to split it into the positive and the negative. X plus 2 is equal to 3, and x plus 2 is equal to negative 3. So I'm going to subtract 2 to both sides. I'm going to subtract 2 to both sides. And then why don't you go ahead and check both of those solutions for me and see if either one of them are extraneous or if they both work. So when you plug them back into the original equation, you should find out that both of these solutions do in fact work. So negative 3 times the absolute value of x plus 2 minus 1 is equal to negative 10. So negative 3 times the absolute value of 1 plus 2 minus 1 is equal to negative 10. So negative 3 times 1 plus 2 is 3 minus 1 equals negative 10. So negative 3 times the absolute value of 3. Well, the absolute value of 3 is positive 3. 3 times negative 3 is negative 9. Negative 9 minus 1 is negative 10. So that's a true statement. And because I'm out of room, I'm going to go back and erase these steps. I just figured out that 1 does work, so now I'm going to plug in negative 5. Negative 5 plus 2 minus 1 equals negative 10. So negative 5 plus 2 is negative 3. The absolute value of negative 3 is actually positive 3. So negative 3 times positive 3 would be negative 9. And again, negative 9 minus 1 is negative 10. So they both work. So our final answer is x equals 1 and negative 5. So why don't you go ahead and give example 4 a shot on your own. Press pause on the video and press play when you're ready to check your work. So your first step should be to isolate these absolute value symbols. To do that, you need to move 3 to the other side. So 2 times the absolute value of x plus 9 is equal to 4. Then divide both sides by 2, and you get the absolute value of x plus 9 equals 2. So you're going to split those into the positive and the negative version, which I'm going to do up here. So you're going to have x plus 9 equals positive 2 and x plus 9 equals negative 2. Then you should have subtracted 9 to both sides. So x is equal to negative 7. Subtract 9. X is equal to negative 11. Then we need to check our work. So 2 times the absolute value of x plus 9 plus 3 is equal to 7. So we're going to plug in negative 7. So negative 7 plus 9 is 2. 2 times the absolute value of 2 would be 4, plus 3 is 7. So that works. Negative 7 works. Then we're going to check the second one. And we're going to have 2 times the absolute value of x plus 9 plus 3 equals 7. So we're just replacing x with negative 11 this time. Negative 11 plus 9 is negative 2. So the absolute value of negative 2 is positive 2. And then 2 times 2 is 4, plus 3 is in fact 7. So once again, they both work. So we actually haven't had an extraneous solution just yet, which is kind of disappointing. So x equals negative 7 and negative 11 are our two solutions. So for number 5, before you get started on your own, I'm going to give you a hint to get you started. You have an absolute value equals 2 terms this time, which is totally allowed. The absolute value is isolated. We're good to go. We can go ahead and solve this problem. To do that, you still have to break it up into the positive and the negative. So what you're going to have is drop those absolute value signs. 3x plus 2 is equal to 4x plus 5. And then 3x plus 2 is equal to the negative of 4x plus 5. So do you see how I made what's on the right-hand side? I'm making it all negative. So now we have to distribute this negative before we can continue to solve. So why don't you go ahead and press pause on the video and then press play when you're ready to proceed and check to make sure your work is correct. Go for it. Okay, so the first step I'm going to do is subtract 3x to both sides. I'm going to get 2 is equal to 4x minus 3x is x plus 5. I'm going to subtract 5 to both sides. So 2 minus 5 is negative 3 equals x. Then over here, I'm going to distribute that negative. Then I'm going to subtract. Actually, I'm going to add the 4x to both sides. I'm going to get 7x plus 2 is equal to negative 5. Then I'm going to subtract 2. 7x is equal to negative 7. Divide both sides by 7. So x is equal to negative 1. So now you should have checked both values, x equals negative 1 and x equals negative 3, to see if they work. The absolute value of 3x plus 2 is equal to 4x plus 5. So we're going to have, I'm going to use a center point here, a smaller point. So the absolute value of 3 times negative 3 plus 2 is equal to 4 times negative 3 plus 5. So 3 times negative 3 is negative 9. Negative 12 plus 5. Negative 9 plus 2 is negative 7. So the absolute value of negative 7 is equal to negative 12 plus 5, which is negative 7. Well, what's the absolute value of negative 7? Isn't the absolute value of negative 7 actually positive 7? Is 7 equal to negative 7? No, it's not. So x equals negative 3 doesn't work. In fact, you would then say x equals negative 3 is an extraneous solution, or you could just say is extraneous. We finally got an extraneous solution, guys. Oh my goodness. I'm the only person who can't keep their AirPods in their ears. Okay. I don't know why that's so difficult for them to stay, but. All right, so now we need to check x equals negative 1 and see if that works. So the absolute value of 3 times negative 1 plus 2 is equal to 4 times negative 1 plus 5. So negative 3 plus 2 is equal to negative 4 plus 5. The absolute value of negative 1 is equal to 1. Yeah, that works. So we do have a solution. So that means x equals negative 1 is the only solution, because x equals negative 3 is extraneous. So unlike a quiz or a test, when I look at your work, I want to see you actually write out that x equals negative 3 is extraneous, and then the only solution that is circled is the one that worked, which is x equals negative 1. Okay. I'm just going to erase this work so it's out of the way of the directions here. So for example 6, I need you to determine if A, B, and C are sometimes, always, or never true, and then you're going to explain to me how you know. So I'm going to go ahead and give you a chance to think about these answers, and then when you are ready to check your work, you can. So hit pause, and then you'll hit play when you're ready to check your work. Go for it. So the absolute value of x plus 2 equals negative 27. Well, right off the bat, I see that my absolute value is isolated on one side, but it's equal to a negative. If absolute value is distance, so the distance a number is from 0, can it ever be negative? No, it can't. Distance is always positive. You don't say that you live like negative 12 miles from school. You just live 12 miles from school. So this is never true because absolute value can never be equal to a negative number. So what about part B? So part B is a little tricky because, and so is part C. Part B says that the absolute value of a number is less than a negative. Well, if you think about what less than a negative 10 would mean, is less than negative 10 is all the numbers to the left of negative 10, like negative 11, negative 12, negative 100, negative 5 million, negative 20 million, etc. Can an absolute value be less than 10? Is negative 10, sorry. Is that allowed? Can an absolute value of x be less than negative 10? No, it can't. So this is also never true. Because absolute value can't be negative, therefore it won't be less than a negative number. Now, what about the absolute value of x being greater than a negative? Well, the absolute value of x greater than a negative, let me think about what that means on a number line. That would mean that the absolute value of x would always land in the right direction of negative 5, which means it would include numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, all the positive infinity numbers, right? Will an absolute value be greater than negative 5? Yeah, it'll always be greater than negative 5, no matter what you plug into here. If you plug in the absolute value of negative 1,000, well, isn't the absolute value of negative 1,000 1,000? Isn't that greater than negative 5? Yeah, it's a true statement. So this will always be true because all absolute values are greater than all the negative numbers. Oops, I did not mean to do that, sorry. All right. That's it for today's notes. Thank you for tuning in today.